All right, everyone. So in this example, we're going to determine some variables for 23-gram ball that's tossed into the air at a speed of 13.4 meters per second. So we want to figure out how high it goes, and then we want to know the speed when it's halfway up, when it's 3/4 of the way up, and we want to determine the total energy. So to do this, we're going to use the conservation of energy. The potential energy and the kinetic energy initial should be equal to the potential energy and the kinetic energy final. So in the case of the entire problem, since the ball is tossed up in the air from the ground, the initial potential energy will be 0. For part A, when the ball reaches the top, its highest point, its velocity goes to 0. And so the final kinetic energy would be 0. So to solve part A, we need only just set the two sides equal to each other. The initial kinetic energy should be equal to the final potential energy. Here we can cancel out the masses. And if we solve for H, we find that the max height and the max height of the ball is 9.161 meters. Since we now know this max height, for B and C we can use that height and the conservation of energy to determine its speed when it's halfway up or when it's 3/4 of the way up. So for part B we want to determine the velocity when the height is 1/2 the maximum height, or 1/2 times 9.161. And so the height halfway up is 4.581 meters. Knowing that it only starts with initial kinetic energy, and if we know the height, we know the final potential energy, we can then solve the equation for Vf squared, or for Vf. Here again, the mass doesn't matter, and we just want to solve for Vf. And so we find the final velocity when it's halfway to its max height, 9.475 meters per second, not half of its initial velocity. For part C, we want to determine the velocity when it is 3/4 of the way to its max height. And so again, this is the same as part B. We're just now changing the height where we're determining what the velocity will be. And so then we just plug everything in and solve it for the final velocity. So in this case, when it's 3/4 of the way up, the height is 6.871 meters, and we can determine the final velocity at that point. And so when we solve, we find the final velocity to be 6.7 meters per second. So this is about half of the initial velocity at 3/4 of its max height. And finally, for part D, we would just want to find the total energy, and the total energy of the system never changes, so we need only choose one point where we measure the energy, and the easiest point to do that would be the initial point. And so the total energy of the system will be the initial kinetic energy. And if we calculate that, and so you find the initial kinetic energy is 2.06 joules. And just to show that you need only choose one point, if we then calculate the potential energy at its max height, we'll still find that the potential energy, or the total energy of the system, the potential energy at the top of its flight, is 2.06 joules.